All right. I think that's, yeah. All right. So, in this problem, it is a substitution problem. I'm sorry, it is a system of equations problem. The first thing you have to be able to do, which you didn't have to deal with today because I told you how to do it, but when you get a bigger quiz on this, which I will give you one, it'll still be an exit ticket, so there won't be a bunch of problems on it, but it will be set up so that you have problems on there and you determine which way you want to solve it. Will you use substitution or will you use, I guess even graphing? I may give you somewhere you can choose to use graphing if you want, although I feel like you need to know how to graph, so I may not give you an option. I may just give you one you have to graph. Or do you use elimination? So the way you determine elimination is probably the best fit is what? What did we say yesterday? It could be that you see what's called, we said inverses. Like if you see the same number and variable in two equations and they have the opposite sign, so that would be the 3y or negative 3y, we'll say, and positive 3y. Those are called inverses, we said. That's a good sign that might be a good way to solve it, is just adding straight down, because then the variable will go away. There's another one I said before that, because sometimes you won't have that, but elimination is still the best way to do it.
You have two variables in one equation.
Well, you'll typically always have two variables in one equation. Because you might have y all by itself on one side, but that's still a variable in that equation. There's another thing, I'm pretty sure I said it, and you definitely need to know it. What do you notice about that relative to, like, let's say I wrote this up, in this, totally making something up. We'll just even put a 1 in front of it.
You said the ones that we cancel out. Oh, never mind. I was using that.
So what do you notice about this one on the left versus that one on the right? Just literally, visually, what do you see about it? So you got a y all by itself over on the right. So that's typically, if you got y by itself, that's not going to be a good elimination. So that's one thing. If you see that, that's either going to be graphing or substitution. What about the one on the left? Like, what does that look like relative to the one on the right? There's one thing that jumps out to me, like visually, and I'm sure some of you, I say it.
Oh wait, both of them on the right.
On this side?
Yeah.
Yeah, it's
And there's the inverse.
On the other side, there's a number with no variable. Yeah, so would be a y-intercept, right? Because y is all by itself. So again, that goes back to kind of y being all by itself, slope-intercept form. What did you guys say over there?
I had said that it's they have the different it's an addition sign and it's a subtract sign.
So again, that goes back to the inverse. If you have an addition and subtraction already set up, then that might be leaning toward elimination. When I look at this, I'll tell you what I see. It looks really organized. The x's are lined up with the x's, the y's are lined up with the y's, and then numbers are lined up with numbers. That's not the case over there. I got a y all the way on the left, and then in the bottom when the y is in the middle. I do have two numbers at the end, I guess, but on the bottom equation, there's only one number on the right side, and the top equation, there's a number and a variable with x. Like, it's just not organized. So I look at this and I say, man, this is all nice and organized, all nice and lined up, variables on top of variables, the exact same variable on top. That's when elimination is going to be your best bet. If your x's are lined up, if your y's are lined up, and then at the end, numbers are lined up, that almost always is going to be an elimination problem. Somehow they've set it up to where you can use either an immediate step like this and just add straight down, or you may have to do one step before that, which is what we're going to learn today, and then do elimination. So we'll go over that more as we get farther into it. But when you add straight down, and most of you got this, we're creating a new equation. We said we can add whatever we want to an equation as long as we do the same thing on both sides. Well, we are. We're adding 8 to 17, and technically this is equal to 8. It looks different. So if you weren't here yesterday, we did a little exercise with money. This looks different than just an 8, but the value of that is 8 because that's what that equal sign tells us. So we are actually adding 8 to this side. It just looks different than that 8 over there. So we can add whatever we want to both sides. So we added 8 to 17. We're adding 8 technically to this in a different format. And we get a brand new equation. Doesn't matter if you use, somebody asked this yesterday, was it a plus 0 or a subtract 0? Doesn't matter. Anything plus 0 is the same number. Anything subtract 0 is the same number. Doesn't matter what sign you use if you're putting 0 here. Yes, sir.
So if you have it in like a different graphic or something, chart it and so on.
Absolutely. You can change. Remember when we did literal equations? It had a bunch of variables, and we solved for one of the variables that was like in the part. That's why you learned it. You could change this into y equals mx plus b. You could solve for y, put y all by itself, and then you would have it in y equals mx plus b format, and you could solve using graphing that way. You do slope and y-intercept. You can change any of these around, and if you do it correctly, you can solve them in whatever way you want. But again, they're normally set up typically to do it one certain way, and that would save you time to just do it that way. But if you feel really comfortable with another way, you can always do that. So 5x plus 0 is just 5x. Last step is always what? Yeah, just remember that. Last step is always divide. If you get down to a step and it looks like you don't recognize it, a lot of times it'll be because it's that division step and maybe you skip the step before. Like here, we didn't have to subtract or add anything here first. We just were immediately at the step where we divide. So x would be 5. A lot of you got that. I think maybe almost everybody got that. Now, though, some of you didn't either remember to get the y or you didn't know exactly how. That's when we go to either equation. And I'm going to show you it'll work with both. And I say, okay, well, if I know x is 5, I don't really need x anymore in either of those equations. If x is 5, I don't need a variable if I know what the number is. I'm going to pick the easiest one. Raise your hand if you pick the top one. A couple people pick the top one. Raise your hand if you pick the bottom one. To me, the bottom one's easier. Doesn't matter what you pick, but there's no negative signs in here. I don't have to worry about any rules like negative divided by a positive, negative divided. I don't have to worry about any of that. I'm going to have all positive numbers if I pick that bottom one. So that's the one I'm going to pick. 3y equals 8. So if x was 5, I don't need that x anymore. Don't know why I just wrote times for x. So I get that. I hope this works. So I get 5 plus 3y equals 8. That's a two-step equation. Typically, you'll have a two-step equation when you do that first substitution step. Always get rid of the number first, not the 3y part. The number, and when I say the number that's all by itself. The constant is the correct math term. So I subtract 5, 3y equals 3. Again, last step as usual is divide. And most of you got that y equals 1 if x is 5. Any questions on that? So very quickly, I'm just going to show you what would have worked for the, I mean, a lot of you did use, a couple of you at least use the other equation. If I would have chosen this equation. So again, x is 5. So I would have changed this x to 5. So it would have been 4 times 5, subtract 3y now, equals 17. Well, 4 times 5 is 20. So I would subtract 20. I'm not going to write it all out. If you want to go back and do it, you can go back and try it on your own. So this is positive 20. So to get rid of that, I would subtract 20. Well, if I subtract 20 over here, I would get negative 3y equals negative 3. So I'd have to divide by this negative 3. Well, I divide by negative 3 over there. Y equals 1. So I get the same answer. Always get the same. If you don't get the same answer, like you're going to test your work, you got a little time left over, and you're like, well, let me make sure I got this right. If you try the other equation and you get a different number, either you solved wrong for x, your x is wrong, or you did some math wrong when you solved for the y. Because you should always get the same thing. Any questions on that? All right, so we'll see how much detail I go into. I may just show you the first part of this and then come back and do the second part. So that one was set up to where it was pretty easy. We did this one yesterday. Again, same thing. That would be pretty easy. We just add, y would automatically go away. Those are inverses already. But that's not always the case. So look at that top problem. I could add straight down. You can always add straight down. This is equal to 10. This side is equal to 10. So I could add straight down. I'm adding 10 to 7. I get 17. Problem is, if I add straight down, if I add this to this, I don't get rid of a variable. I just have one equation, two variables still. I can't solve one equation, two variables.
So you can just subtract.
Does me no good. Can't do anything. Done. Can't do anything. I got myself stuck. We don't want to get ourselves stuck. So we have to do something to one of these equations. Mathematically, we have to do it. This is not just magic. We ain't using magic in here. We use math. Sometimes math seems like magic, but it's not. We've got to do something to change this equation so that when we add straight down, we lose a variable. We got to set it up so we do have inverses.
Do you put 1 in front of the variable?
We could. If you want to put a 1 in front of all of these, they do all have a 1. Again, that doesn't mean the variable equals 1. That means there is a 1 of a coefficient of 1 times x. Or basically it means we have 1x, 1x, and 1y. Here we have 2 y's. Still stuck, yep. Still would be 2x.
You would subtract the two equations.
Now that's what you came up with the other day. This would be a situation where you would subtract. If you want to subtract, you could say, I say that subtract that, that subtract that, that subtract that. You got to subtract every term. I'm not going to teach it that way, but if you were taught that way or if you understand that way, that's fine. I'm going to teach it a different way. What do we need? What's really close up there to going away? Somebody tell me that.
The x's.
The x's. We have the same number, right? We have the same number. We just don't have opposite signs. So we're really, really close on the x's already without doing a whole lot. So what do we need?
Make them negative.
We need a negative sign on one of those, right? So I'm going to tell you the math way and then the shortcut way. The math way to flip a sign is you multiply by a -1. If I multiply any number by -1, it flips the sign. So if I multiply 2 times -1, it's -2. If I multiply -10 by -1, it becomes +10. So multiplying by -1 flips the sign. So I'm going to multiply every number, and it's got to be, I'm sorry, every term, I should say. Every term in one of the equations, doesn't matter which one, I'm going to multiply every term by a negative sign, meaning I'm just going to flip the sign of everything. So I'll rewrite the top. I can do it to either one. I'm going to choose this equation on the bottom, just because I know if I do that, it's going to keep my bottom equation positive. I'm not going to even go into an explanation of why to choose one. It will always work. You don't have to worry about it. You may have to deal with negatives sometimes, but the equations aren't going to be so difficult that you won't be able to deal with that. So I'm going to say, all right, well, my top equation is this. I'm not going to touch that. I guess I'll write the 1 in. I'm going to now, though, multiply every single term. So when I say every term, this is a term. This is a term, and I'm including that positive, and that's a term. So there's 3 terms in that. I'm going to multiply every one by -1, which means the sign is just going to flip for every single one of them. All right, thank you. Ooh. ASAP. This will be recorded, or if you can come in at some point, I'll get you caught up. All right, so if I multiply I don't know why I just put those on. If I multiply every one of those by a negative sign, I'm going to rewrite the new equation in blue. I just flip the sign of everything. It doesn't mean you make them all negative every time. This time we do, because if there would have been a subtraction sign, I would flip that to positive. In this case, though, everything's positive. So I would say -1x subtract 1y, because again, that was positive, so that becomes negative. And then +7 becomes -7. Just flip the sign of everything. Once you have the same number here, which we do. Now I have an equation where I'm set up to add, and from there on out, you do the same exact thing. So I'll let you guys finish that. So go ahead and solve for x and y now. So you just, again, same thing you just did, add straight down. So your new system of equations is everything in that box. That's what we changed it to. And we're allowed to change it as long as we do the same thing on both sides, which we did. We multiplied the left side by -1. We multiplied the right side by -1. We can do whatever we want, as long as we do it on both sides. And this one should be super fast, because you only have one number in front of the variable, 2. Everything else has a 1 in front of it. And there will be quite a few problems on the next exit ticket on this, since we kind of skipped this and I didn't put it on the big quiz. Your exit ticket on this is going to be a little longer than probably what you would normally have on this. But that means there will also be quite a few easy ones and then a few that are a little tougher. I'll give you a minute, I'll walk around, see how we're doing. And then that's really your answer. You could divide 3 by the 1 in front of the y if you want, but it won't change the answer. And then plug that in and get your other variable next. Oh, is this up here? I was thinking this first one. That's the second one. So what you use first? Okay. Oh yeah. No, you should get integers for both. I mean, I guess we can tell you what the answer is, just so you can kind of check your own work. So you should get y is 3, then you'll plug that back in, and you should get x is. Well, that doesn't make sense.
Yeah, I got y. I got 3 too.
Well, no, 3 works, but
I didn't finish it though.
4 for
yeah, 4 for x, not 1. I'll try that again. Because if I look at the bottom equation, 3 doesn't work for that.
I got 3 for x.
No.
So use the top equation for 3 when we plug it back
4 would be
here.
the right answer. Because I can look at the bottom equation. If y is 3, well, what plus 3 is 7? Well, x would have to be 4. And then if I try that in the top one, it works for that also. So just check your math on it. So did you see how we're doing the, so pick either equation, no matter which one. We're saying y is 3, then pick an equation, plug in 3 for y, obviously the bottom one is the easier one, and then see what x is. Did you see a mistake on it? Mine? So this is a 3, that's a -7. So 10 plus -7 would be 3, and then you'd have, and then this is subtract y. So 2y subtract y is just y.
Yeah, I got 4 for x.
And then these go away, because that's a positive and a negative, they're opposites, they're opposites. Inverse is correct. Well, so is this line, is these combined, is that what you did? Okay, so this goes away. This is a +1 and a -1. So that goes to 0. This would actually be 2 and -1 would be +1. And then this would be 3, 10 subtract 7, or 10 plus -7 is 3. So that's why we're not getting 3. Yeah, so you got 3 there, and you're getting 4 good. 3.
Oh, okay, I got the, okay, never mind.
Oh, you plugged it in for the x instead of the y.
Yeah.
I came home Saturday.
Are you doing other problems? Yeah, if you want to start on that sheet, if you kind of think you can do some of them, you can feel free to start on that worksheet.
I got one.
I think it's already done.
I did the same thing we did for the other way. Right here.
If you didn't get a sheet, they're up here. I think everybody grabbed one, but they didn't get one, they're up here. Yeah.
This is for the one.
Are you good?
Yeah.
I'll try to work.
Like, I took.
Yeah, if you want to start on that, you go ahead and start that.
Yeah, I
Some of them
started
I'll
already.
probably have to show you how to do, Bill. You got this right, now you're forgetting the y. Don't forget, you didn't get rid of that y, it's still, you have two y, and y on it, you took a y. So y, so that's how you get y is 3. So now, knowing that y is 3, is plug that information into your equation, and then you can solve for x. So did you get the next part of that last one? So you should have got 3 here, I think that's 5.
I really
10 plus -7 is 3. And this x's go away. Positive x and negative x and opposite. Anytime you're adding opposites, they go away. So positive x and negative x, you can't take it's like in money. I give you $1 and then I give you a bill saying you owe somebody $1, you have to give that $1 away. Okay? So positive, negative, and the same value. Which is what we're trying to do. That's the whole goal of elimination, is to get rid of one of the variables by doing exactly that. I'll let you work for a couple of minutes and then I'll do one of the harder ones on those worksheets. So why don't, you should be able to do, actually, let me do one from the worksheet. How about we do that? Well, I'm going to skip number 1 because normally the beginning ones are easier. Yeah, number 1, you just combine them and they go away already. You should just be able to add that straight down and then you just have the y equals something. The math here would be a big negative number, -36 if the math is.
Yeah, it's -3.
All right, so 8's a pretty good one. So let's look at 8. So I'm going to do one for you. So on 8, we already have numbers. Well, I don't want to do that. Let's not do 8. 8's just like what we did. You're just one of the equations, you'll multiply through by a negative. Change, basically flip the sign of everything. Because you already have the numbers set up, right? You have a 2 and a 2 in front of that. If you have the same number in front of the variable already, like in the 2 different equations, 2 and 2. Let me zoom in.
So they cross out?
Not yet, but it's just like what we did. What did we do in the last problem? Where we just had x and x. The x were both positive. What did we do?
We multiplied one by a negative.
Yeah, we multiplied one of the equations by a negative. So basically we flipped the sign of every term in that equation. So for one of these equations, doesn't matter which one, you would basically flip the term or flip the sign of every number. So in that case, they would also all become negative.
Oh.
You see what I'm saying? Because then you'll have in one of the equations, you'll have a negative 2y, and the other equation you'll still have positive 2y. So now they'll cancel out.
Wait,
We need to do one that's a little harder than that.
Wait, on number 1 on the packet, it's going to be a negative. I mean, not negative. It's going to be a fraction.
No, I don't think you should get any fractions in this. Number 12, is that a little bit harder one?
I said number 1.
Well, number 1's already set up. I'm not gonna. Okay, so here's a good one. I don't even like that one. That one will be easy. Let me do an even harder one. 12 in that. Oh, that wasn't 12. I'm sorry.
23.
All right, let's do 12. I like 12. All right, because in 12, there's 2 things that we have to do. I was trying to find one where there were 2 steps, not just 1 step that we're going to have to do. Do I have the same number in front of either of the 2 variables? Like, do I have the same number in front of the x's? In front of the x's, I have a -7 and a -2. Those are not the same numbers. And we need the same number and we need opposite signs in front of a variable. Like up here. Whoop. There, -6x, +6x. That's what we're trying to get to. Same number in front of the variable, but opposite signs. One's positive, one's negative. Kind of like this one up here. +4x, -4x. Same number, but opposite signs. That's your goal. You're trying to get one of the variables. Doesn't always have to be x. Either x or y, you want the same number, opposite signs. And sometimes you might have the same number, like here. So we have the same number already. We just need to change the sign of everything in one of the equations. So either -7, -2, -24, or we could have changed the sign of all of those. And then we would have had opposite signs here because we already had the same number. Sometimes, though, you're not even going to have the same number. Like number 12. We don't even have the same number yet in front of a variable. So that's a two-step equation, or a two-step process. I've got to, first of all, get the same number in front of the y or the x. Or, yeah, and then, I'm sorry, not or, then I have to get the sign correct. So what would I do? What could I do to get the same number in front of really the x or the y, but the y is much easier, I'll just tell you that. Like if you're just looking at the y, how would you get the same number in front of the y? I'm going to leave it pretty open-ended first, then I'll give you one hint.
You can add.
You would multiply.
Can't add, always multiply.
Multiply by 3.
If I multiply, because this is 3y, right? Well, if I took this y and I said 3 times y, well, then that would get me to 3y. So you've got, so here's your note. This is where you would take a note. So next to number 12, you need to write something like, find the number that you would multiply, and I'm just going to tell you times y in this one. It won't always be times y, though. Find the number you would multiply times y in the top equation, though, to get 3 in front of the y. I mean, it's always going to be, it's actually not always going to be whatever number's in the other equation, but a lot of times it will be. I'll give you, like, we could have done it with x. And I wouldn't multiply this times 7, though. That doesn't get me to 7. So it's not always the number that's in the equation below. Like here it is. If we multiply times 3, we're going to get 3y there. That's not always the case, though. You'll see when we do some hard ones, which we may not use. The more, again, the more of these you do, you'll just, it's easier to just do them than me to try to explain it in words. So if I multiply the top equation by 3, I've got to multiply every term by 3. Do not just multiply this term by 3. That's not following the rule of multiplying the left side and the right side by the same number. Technically, you're not even multiplying the left side by the same number if you only multiply this. The way it would look is like this. I would be saying, well, I'm going to multiply this top equation by 3. That's an x there. And the left side by 3. So that's what you're doing. You're multiplying this in parentheses, and if you remember the distributive property, that means we're multiplying 3 by both of those terms. So that's why you can't just multiply times the y. We got to multiply that whole left side by 3. So if I do that, what is 3 times negative 7? Negative 21, and don't forget the x. So it's actually 3 times negative 7x, I should have said. So negative 21x is now my first term, plus 3y, which is, that's the whole goal. We wanted to get to the 3 because there's a 3 in the other equation. And then that's a little tougher for you. I'll do the math for you there. That would be 57, negative 57 over here. I might let you use calculators to do this page if it's got some bigger numbers. So now we have that equation changed. We've multiplied by 3. We didn't touch the other one. And you will sometimes multiply both equations by something. So that would be, the bottom equation didn't change. Nothing changed in that bottom equation. You only have to change one equation in this problem. There are problems where you have to change both. But are we where we need to be? If I add straight down, am I going to get rid of one variable? I'm still not. Now we're in a problem like we just did, where we got to multiply one of the equations all the way through by a negative. Doesn't matter which one. I would just, in this one, I just picked the top one for no particular reason. There actually is a reason, but I'm just going to pick the top one. So I would multiply every term by -1. That means you're flipping the sign of every term. So negatives become positives, positive becomes negative. So I'll change colors again to show you the two new equations. So that would now be positive. I'll go ahead and write the positive sign in. 21x subtract 3y equals positive. So again, none of the terms changed as far as the numbers go, but their signs all changed. That was negative, now it's positive. That was positive, now it's negative. That was negative, now it's positive. And if you'll notice when I write the other equation, now which the other equation still hasn't changed. We've never touched the other equation in this problem. Now I have it set up to where when I combine them, I have opposite, well, they're called inverses, we said, but they're opposite terms. You can think of them. Negative 3y is the opposite of positive 3y. And they will then cancel out when you add them together. And then you can solve for x just like we did. Once you get x, you can solve for y by plugging it back in. I'm not going to solve that one for you because you should know how to do it from there. I just wanted to show you how to set it up. Now there's one more level of difficulty, which you will see on the exit ticket. If you look at, not that one, this one right here. So in the last problem, we were able to multiply one equation by 3, and then we multiplied by negative, and we got what we needed. There is no number I can multiply this equation times to get, like, I can't get the 3 to a 5. Nothing time, I mean, there is a fraction, but we would never do that. Nothing times 3 is going to get me to 5. Certainly nothing time, and I could, again, there is a number, but nothing that's an integer. So again, I can't do that in that problem.
So you gotta multiply both.
That's when you multiply both equations. And I might just teach you the quick version of that, since I'm going to let you use a calculator. You would wind up just multiplying, and you could pick either variable, whichever variable you want to use. You wind up multiplying this equation by the 5, and then this equation by the 3. Basically, you just use the numbers already in the equation to determine what you're going to use to multiply. So we'll see if we get, well, we'll see if we get there. I'm not even worried about that one yet. Let's see how we do on these. If I feel like by like 8:30, if I feel like, man, we're really good on the ones that where you have to just multiply one equation, then maybe we'll do this. I don't know that we'll get to it today. I mean, we will eventually.
Did you go Maze or?
Yeah, I don't think I was holding anybody's. So here's what I want you to practice. If you feel like you don't have the ones down where it's already set up like this, where they're already set up as opposites, so basically the first 4 problems I think are like that. Yeah, the first 4 problems are like that. So the first 4 are the basic ones you absolutely have to know how to do. Yeah, if you feel like you still need to work on those, then work on those. If you say, you know what, I've got those down, I just add straight down and then I solve for the variables, then go to the next set of problems, which I would say is probably 5 through probably 8, it looks like. If you'll notice in 5 through 8, you already have a number that's the same, but you don't have opposite signs. So here we have the same number there, but we don't have opposite signs. So that's where you multiply one of the equations through by a negative. So basically you're just flipping the sign of everything in those. And that's 5 through 8. Then the next level is what I just showed you a second ago. We don't have the same number at all yet. Now we might have opposite signs. If you have opposite signs, that's where I would concentrate because I've already got opposite signs there. In one of these equations, I got to multiply by something so that I can get the same number in front of one of the variables. I want to ask people what they would do in this problem. Somebody's probably going to get it for us, I think. So everybody look at number 9. Again, we want to multiply and get the same number in front of one of the variables. So either the y or the x, because right now we don't have it. We've got a 1 in front of this y and a 7, or really a negative 7 in front of this. We got a 5 in front of the x and a 10 in front of the x. We need the same number. What can we do? What do you think? We could multiply. If we want to get a 10 here, we could just say, okay, well, I'm going to multiply this 5 times 2, and that'll give me a 10. But then I got to multiply every number by 2. So I could wind up with this. So by 2. Now, I still don't have the sign, so I'd have to multiply one of them through by a negative. But what else could I have done? Is that the only option? What else could I have done? No, that wouldn't do me because I don't have the correct number there yet. If I just did that for me. Now here, yeah, I would multiply by -1 there. Once I've got the same number. But I remember I got to get the same number first. There is another option that I would argue is a better option. Is x the only variable in the equation?
No.
What's the other variable? How could I get the same number in front of the y if I have a 1 there and a 7 there? I could multiply by 7. Because remember, you got two variables. Don't get focused on just trying to get the first variable matched up. So I'm going to erase that. If you already wrote it down, then you have it. If not, then you can write this one down. If I get the 7 here, I've already got opposite signs on the y. I won't have to multiply through by a negative because I've already got opposite signs. So if I multiply all of this by 7, now my numbers might be a little bigger sometimes, which they are in this, but I have the opposite sign. So for me, that's worth it. So 7 times 9, you'll have calculators, so bigger numbers shouldn't matter. Oh, well, you can go ahead and grab calculators when you want, by the way. The little blue ones in there. So now I have the same number. I have 7 and 7, but I already have opposite signs set up if I use the y variable instead of the x. So don't get focused on always trying to force one variable to work. Pick the variable that's easier, either because it's easier to figure out what you need to multiply, or because it's already got a positive and a negative sign set up.
How would we do number 7 again?
7?
No.
Oh, when they're both, you just need to pick an equation and multiply everything by a negative. So you're just flipping the sign of everything.
Okay.
That's what the effect of multiplying by a -1 is that the sign of everything flips. And that's pretty much true for all of
So
math.
since the negative would be a positive?
Yeah, a negative becomes a positive and a positive becomes a negative. So either equation, again, you wouldn't do it to both equations. You're going to pick an equation. And once you flip the sign, you're going to have either a +6 down here or a +6 here, depending on which equation you choose. And then these will flip to negative, depending on which one you choose. This would flip to positive. That would flip to negative. But don't do it on both equations. You're picking an equation. Pick one equation to flip. If you flip both of them, then you still have the same sign right here. That doesn't do any good. They'd both be positive, which doesn't work. Just go ahead, work. We'll see how we do. If I have to do another one up here, I'll do another one. But again, if you don't have these down, start with these 1 through 4, where they're already set to cancel out. Like those y's will be canceling out. Those 4 x's will be canceling out. I think in the other one, it's a 4x that cancels out. Here, the 6 x's would cancel out in number 4. So some of them will already be set up to cancel out like 1 through 4. And you'll have a couple probably on the exit ticket where I set it up to just cancel out immediately. You don't have to do anything, but just add straight down. Then you'll have some where you have to know what to do to get them to cancel out. So the more practice, the more you'll start to get the hang of what's going on. Do I have anything up there still? I don't think I solved any out, right? So I'll leave that one up right there. I didn't finish solving it out, but it went through the process of how to multiply one equation by a number. And then if we are really, really in good shape, I'll show you how to multiply both equations. But I don't think we'll get there.
This should go. Don't you have to do that for number 6?
You shouldn't have to multiply 6 by a number. I think just a sign. Aren't there already two numbers that are the same in front of a variable?
No.
No. I thought. Yeah, y. What's in front of the y? Both y's have a 1 or so, right? So again, I'm just going to tell you this right now. 1 through 4. Oh, and by the way, I will let you use your, listen to music. I don't want to see you typing on phones, like texting and stuff. You want to listen to music, since everybody, I think everybody's adult today. So I'm fine with you listening to music. But set a playlist and let it go. Don't want to see you constantly on your phone. Not you.
Maybe that's what she is.
Yeah. What you just download?
I went to the spot, it came right back because you kept saying that I was going to take it to you.
I was timing. You're on the clock.
I come back.
They've already started putting some people on bathroom
80.
probation
No.
administration was. No, administration has, not me.
Oh,
Like we get emails every once in a while saying, if this student asks to go, please call me and we will have someone come escort them. Because apparently it's happening in all their classes.
Not me.
No, you were not on that list. But it happens every year, normally about this time, beginning of the second semester.
Class. I said I just came on. It's like-
So did somebody just ask a question that I was in the middle of answering? So make sure you can do 1 through 4 once you're comfortable with those. You don't have to do all of 1 through 4, move on to the next. So 1 through 4 are done pretty much the same way. 4 through 8 are done pretty much the same way. I think then 9 through 12 are pretty much the same, where you just multiply one equation by a number. Oh, actually 13 is the same, and 14. So it looks like 9 through 16 are all the same. And then 17 is where it gets hard. So you probably don't want to try anything past 16. 17 is, I haven't taught you really how to do. If you want to try those, like if you think you got everything down and you think you're big brain, then
Yeah.
You said what?
17 is where I haven't taught you how to do those. You think you can figure it out? If you got all the other ones down and you think you got this stuff, you might be able to figure out how to do 17 without the lesson. I kind of told you a minute ago. Oh, that. Okay.
but that's the.
So yeah, you're after 9.
I don't know how to do that.
So make sure you can do the first 4 since I think you were still working on that a little bit.
Oh yeah.
Oh, if you want to know answers, I'll give you some answers real quick. So raise your hand if you're done with number 1. I'm not going to give it until a few people are done.
I need to do it.
All right, I'll still give you the answer. That way, if you go back and do it, you can check your work. So for number 1, you should have gotten x is 6, y is -6. Actually, I'll give you a few answers.
What about 8?
Told you,
What?
X
Eight.
is 6, not 18.
There are no fractions on this. You should not be getting any fractions.
It's only.
So number 8, x is 6, y is -9. Again, I said you could use calculators, remember? So if you want to grab a calculator to help you with some of the multiplication, especially since that'll help you with the multiplication rules also.
I got it. Well, got the first one.
Does anybody else want an answer? If they finished a different one than 1 and 8? 9. X is 1, y is 4. And I'll still probably do another one in a minute. It may not be one of the ones that's hard yet, like 17 on, because that's definitely where they start to get a little more difficult. Yeah. Because in 17 and all the rest of them, it looks like you got to multiply both equations by something. Everything before 17, you just have to multiply one equation, or you don't have to multiply by anything. On the blue calculators, be careful about the way you put a positive or negative. Remember, you don't use the subtraction sign to put a negative in. I believe on all the blue ones, you have to put the number in first, and then you hit that little button that has a plus and then slash subtract sign. So it's like up here, I think, on all of these. I don't know about the other calculators. So you hit the number first, then you hit that button, and that flips the number, the sign of the number. Do not use the subtraction sign, though. That will not work. You might get lucky, but it doesn't work. You just got lucky with the math. Got y is 1 for number 2. Let's see. This one has negative 1 or positive 1. Yep, your y was correct. Your x should be 7. Make sure you know how to use these. I think it was 6 and -6 now. If you do one and you need an answer, like check your answer, let me know. But again, you should not be getting any fractions. So if you're getting a fraction, just check your math. I mean, I'll come check your math.
Mr. Gill, you got scissors.
I do have scissors. Oh, I'm gonna stop the recording. Even if I do another one, I'm gonna stop the recording. Yeah, I'll stop the recording. I'll do one of the more difficult ones another day. I actually recorded the same lesson last year, so it's got a full, even the more difficult ones are in that. So for some reason you want to try to get this all done or work on it on your own, get ahead of the game if you know you need to get your grade up. There's a recording from last year that's system of equations elimination, and it has how to do the one that I haven't done yet. But I'll do that probably next class. I might do it today. We'll see if everybody's in good shape.